In this example, assume that we like to conduct an experiment and we need to collect data. And I would like to know how many data I need to collect based on historical information and the kind of confidence interval I would like to construct. This is historical information and margin of error I expect to have. So first thing first, let me give you the formula for calculating sample size. That is Z. Let me rewrite this. That is Z with a subscript alpha over 2 sigma population standard deviation over EME, which is margin of error squared. So this is the formula from your book and most of the statistic book. However, I'm going to modify this formula just a little bit. I'm going to put a negative sign in front of Z alpha over 2. It wouldn't change anything because when you square the negative sign, it goes away. But why do I do that? I'll explain it in a minute. Here we know sigma is 46.9. And I would like to construct a 95% confidence interval. And that means, keep that in mind, that means alpha equals 1 minus 0.95. So it's 0.05. You always make sure the sum of alpha plus this converted to decimal equals 1. So this is how you come up with alpha. And margin of error should be 5. So we have just about all of the information except negative Z alpha over 2. So what does negative Z alpha over 2 mean? So here I have a normal distribution and my 95% confidence interval will go from here to here. Remember, the bell-shaped distribution is symmetrical with respect to the mean. And this is my Z alpha over 2. And this is my negative Z alpha over 2. One is the negation of the other. Now the reason, instead of finding Z alpha over 2, I want to find negative Z alpha over 2 is because with your graphing calculator, if you give the area to the left, which is alpha over 2, this is another alpha over 2. That's why we divide it by 2, because we have two areas. If you are given the area to the left, we could use inverse norm to find negative Z alpha over 2. So this, the entire thing, including the negative sign, equals inverse norm. Alpha over 2 in this case is 0.025. I could have put in, because it's standard normal, I could have put in 0, which is the mean, and 1, the standard deviation. However, with a graphing calculator, if you do not put in the mean and the standard deviation, it will assume 0, 1. So now we have all of the information we need to type the answer into your graphing calculator, to type the expression into your graphing calculator. So let's do it. So parenthesis, second vase, inverse norm 0.025. Close the parenthesis times 46.9 divided by 5. Close the parenthesis and remember to raise everything to the second power. So my answer will be 337.9. Now remember, when you sample, when you survey people, you cannot ask 0.9%. So you always round your answer up to the next whole number, regardless you have 0.9 or 0.1. So here is my final answer. 338.